Good afternoon and welcome to my presentation. And today I have a lightning talk about our work around PGM. And we built an integration tool for CGMES import for a power grid model. So about me, I'm electrical engineer at SOPTIM. And I work as project lead for SCADA systems development and maintenance. And I'm experienced with online state estimation. And I also build open source tools for the energy sector. This was our task. We had an internal study to import CGMES data into PGM. But the first approach doesn't work because CGMES takes only electrical values, whereas PGM needs the manufacturer data from no-load tests and short-circuit tests. And so we can't import CGMES data in a direct manner. So we had to work around it. And the solution was to introduce a new component. It's called the generic branch. And with this solution, we can direct import the electrical parameters. And this is the common components you can all model with this generic branch. So you can model AC line segments or 2-winding or 3-winding transformers, as well as equivalent branches. So, and there's a detailed documentation in Power Grid model itself, so you can look up for more details. And what is the way we deal with CGMES data? We use the RDF graph technology. We import the data files into a graph database, for instance, Jena-Fusiki. And then the CGMES data is transformed. And so you need an endpoint for Sparkle. And your client only needs to implement this Sparkle queries to get the data. And in more detail, yeah, the first step in the conversion process is to set up a Sparkle query. Then we generate the data for the generic branches and transform the data into the PGM JSON format. So PGM can run with it. And around that, we built a totally integrated tool for Power Grid model where you can import CGMES data. It takes an RDF data storage and integrates PGM, of course, and you can handle with simulated or imported real measurements. And then it executes the PGM state estimation and gives you the detailed results in some reports. And also we generate now the SV profile with the new results. And yeah, it's open source, so there's the link. You can scan it and be happy with it. And for today, we built an example, a web interface, which I will show you. With that interface, you don't need to have to download the software, and we will. Yeah, what's it? Sorry. Yeah, we will put this web interface online, so you can use it later. But we are not finished until now. And if you have some questions, we also have an email address. So ask me whatever you want about Power Grid model. And so I will give you a short demonstration. I tried to give you a demonstration of this web tool. This is the GitHub repository. You can download this suite I show you today. And this is the web integration tool. I will demonstrate you You can load a conformity test from NSOA, for example, and then upload it to the internal database, and we get some error. Yes, it's bitte? Habe ich schon gemacht. Okay. Now it's running. So I have to refresh this site. And this dataset information, this descriptions for the profiles we imported. So we have the EQ, the SSH, SV, and TP profile, and a boundary profile. And it's still missing the OPE profile for the measurements. So, but we can simulate measurements from the SV profile. So I have to click this box here, and now I can run, and hopefully it will work. And then it gives you some statistical output about the value of the minimalization function and the expected values and the range. And also there found one bad measurement here. And here you can download all the results you want to have. And there are a lot of output here. There's some output in the Excel format with all data in it. And we also have the SV profile and the measurements in the operation profile. And another case is this is a simulation measurements. You also can load the measurements and update this operation. And now we disabled measurement simulation automatically, and it reruns again. We have put some features around it which you could not find in Power Grid model itself. So you can suppress bad data by enabling it and rerun it. I hope it works. And now, yeah, now you see the bad data is suppressed. This is because we mark that bad data in the output, and then we give it another weight, a lower weight, and so it's suppressed with the next run. And so you can also make some parameters here. So we can, a nice parameter is to do the network splitting. If you have a data set that's not converging, you can enable network splitting, and the whole data set is splitted on substation level. Or you can also choose some branches you want to disconnect from the network, and they're replaced with substitute values. So you can give here some parameters for substitute values too, and we also add a feature called passive nodes. So in regular data sets, they are often missing some loads or sources, and so you can add on the passive nodes where no injections are placed, we place a so-called zero injection and give it a small sigma, and that stabilizes the state estimation very well. Okay, thank you. That's my talk. Do we have some questions?